Hey, hi folks. Happy New Year. Excited? Don't sit so far away. You're gonna have to be closer. This is a very small class and we're gonna learn together in an amazing and fun way.
I don't want to sit in front of anything. I'm way too tall.
It's not about being tall. We won't be looking at anything at the beginning. We're gonna be forming concepts with our brains.
Okay.
You can still be at the edge of the 6 people who will be in this room. Yes, yeah, that's why you can't be that far away. Because we will be using money, fake money, to learn about probability and later on statistics.
So no notes today?
You can have notes. I think, we'll go through the syllabus at the very beginning. We'll talk about the content calendar, and then we'll do some tricks and games to familiarize me with your ability to understand probability and statistics.
All right.
Okay. So let's start with the syllabus. When does class start?
10:30.
2 minutes ago. And what is my rule about class starting?
Either before, like 2 minutes before. So
Yeah.
on time.
Yeah, so on time is late.
Yeah.
Right? Because no one ever shows up with their paper out and their coffee in hand and they're ready to go. And if you're there a few minutes early, right, then you can ask me questions about the homework, right? Okay, good. We're gonna have student help sessions, so I'm gonna send out a when to meet to find out when I can accommodate the most of you, the most times. Or we'll have, by demand, that's always a perfectly good time. So sometimes folks are like, well, I can never make your help sessions. Do you mind just doing a weekly Zoom meeting? And I'm perfectly okay with doing that as well. This is our standard words about this. This is Math Methods 2. So I assume that you all did well in Math Methods 1. Anyone do really poorly and they're scared? Okay, good. Anyone not want to admit that?
Oh, no, I did that. I got it.
You did bad?
I got it.
Okay,
No.
good.
I got a B plus.
No, B, but it was a low one. It was
Alright.
like scratching.
Okay, so this will not build off of that class at all. Just because I'm curious, because for some people, a lot of the way that we think about mathematics, and we'll talk about this when we get into the idea of probability in the first place, we think about it in the context of, okay, physical interpretation for a lot of our physics, right? So we'll think about E and M, and we'll say, well, I have some understanding of how an electron is supposed to move, or maybe magnets repel each other, right? That has an intuitive sense. And maybe for the math part, especially when you start thinking about all these equations, you're like, well, there's no fucking intuition for that. That just seems like gobbledygook, right? So that's why we're going to bring money and betting into the first section to build intuition. Because even though I love probability and statistics, when I was reading the probability and statistics section of your textbook, I was falling asleep. Okay, so it's very easy to just mentally check out. And we want to avoid doing that. Okay, so you'll say, well, is this class right for me? Can you read that good or should I? Let me do a zoom.
Yeah.
Let's do a 150 zoom. Yeah, big words. All right, is the class right for you? It has, I'm supposed to teach you this. This is from the course catalog. Complex variables. Are people familiar with that? Okay. Tensor spaces, tensor analysis. You know what that is? Okay. Hilbert spaces. Have you ever heard of those? Where do we use Hilbert spaces? That's okay. This is a special form of the tensor, particularly that you have to invent Hilbert space before you get general relativity. Bayesian statistics is what we're going to start with. The idea that statistics can be understood, and I will show you why that is not a given. We will have a very philosophical conversation in about 3 weeks about the difference between Bayesian and frequentists' interpretation of statistics. And then group theory. And group theory in particular is really relevant if you're interested in the fundamental forces. If you want to know more about how all of the universe as we understand it today is structured, you should know about group theory. Now, we're going to go around the room. We're going to understand one another's goals after grad school, and we'll adjust some of the content of the course. But we also have to recognize that I am not a nuclear physicist. So if you are a nuclear physicist and you want more group theory, we'll have to add on to that as a supplement, right? Because we're going to focus a lot on the things that I think are really important, like Bayesian statistics and how that applies to data interpretation, especially in physics. We'll notice that these are techniques applicable to the problems of physics and engineering, So in particular, I'm not just going to show you a tensor space and be like, these are the properties of tensors, right? Because you're going to be like, oh, that fucking sucks. So we want to put them into context. So you feel like, oh, well, maybe I didn't really understand what a tensor was, but now that I see it used, I can get it, right? Okay. You've done this quarter prerequisite, I guess. I mean, none of you are here for quarters, right?
No.
Okay. You were here for quarters? Okay. But you did 3,100 with Katie? Okay. So everyone's fine. Okay. So I'm gonna start. We'll look at the content calendar in a second, but here are the textbooks I laid out. There's a few of them. In general, I won't require you to have any of them. So I think you probably already have this one. Right, the last. Does everyone have this one? Anyone need it? Need it? But I'm going to be teaching from this one. Is anyone planning to go to grad school? Okay, you will need this book. You will get this book. Everyone has this book. You see, I have 4 copies of it in my office, and that's just because all of my graduate student friends, you get the same book. This is a lot less easy to read than this one is. This one presents it in a much more applicable format for an undergrad, but this is much more comprehensive. I've also included some fun books in there. So The Drunkard's Walk is one of my favorite books of all time. It's about how randomness shows up in our lives and how human brains are not really good at discerning patterns. So what I mean by that is they are both good at finding patterns where there is no pattern and also bad at spotting patterns where there are them. So we tend to think of ourselves as very analytic. We become very confident in our own abilities, and we forget our biases, particularly when it just comes to simple things. And we can show some examples of that later on. We'll talk about gravity when we talk about Hilbert spaces and tensor analysis, because that's one of the best applications of this, in my opinion. And then if we want to talk about nonlinear dynamics and chaos, we can do that as well. So we can do things like understanding the Mandelbrot set. You may have already seen that in computational. And all of these techniques can be turned into computational techniques. So depending on your level of interest and ability, we can expand on any of them. We're going to include Wolfram Math World here. If you've never used it before, this is the same person who made Mathematica. You'll want to be closer. Okay, Wolfram Math World is it's a great library that you just type in the word like Markov chain Monte Carlo, and it'll show you. And maybe I have an example of it here. Oh no, I'm not showing my whole screen. Here's an example here. Sorry for folks online who can't see that, but you can get anything you want, and you can talk about algebraic geometry stack, and it just shows you in mathematical terms what the hell that means. So we use a lot of different references here to supplement your textbook, because you'll want to have these as tools for the rest of your life. Questions about that or anything I've said so far? Okay. I'm gonna expect you to come to class. We're gonna do stuff in class. We're gonna be safe with one another. If you have COVID, please don't come in. If you have anything else, please don't come in. You'll notice that I don't ever penalize you for lack of absences. If the work gets done and you understand the material, you'll be fine in this class. I would argue, and I continue to argue this every single semester, that reading ahead of time is helpful. Now, generally speaking, this is not always easy, right? Because what's the motivation to read ahead of time? So I'm not gonna, hit you with a stick or treat you with a carrot, other than to say you will get it a lot better if you just start reading the book. Because the more exposure that you have to this material before I start talking, the better you can use it when you see it in person, right? Okay. We'll do a lecture format. We're gonna do a new type of technique for the first 6 weeks. I've never done it before. I'm excited. Maybe it's a horrible idea and it bombs 2 weeks in. We'll find out. One of the fun things about working with a group like you, who all understand the point of this class, which is to build your skills, is that if it's not building your skills, you can give me feedback right away and we can adjust immediately. Okay. I think most of you are on Slack. Everyone's on Slack. Everyone's on Canvas. Okay. Contact policy. We had a strike. That happened. That disappeared.
How do you feel about the tentative agreement?
That is an ongoing conversation. So, you know, the fine details haven't come out yet, but a tentative agreement basically means that we can return to work. That does not mean that the strike is over.
Okay.
What I mean by that is there is an opportunity for CSUSB faculty and all faculty in general to reject the deal. Right? They make no, the CSU made no concessions about the ratio of counselors to students. They didn't address several other items. So some people are very unhappy, some people are perfectly fine. Right? Okay. So I'll change some of this language. All right, let's talk about homeworks. You're gonna get a weekly homework. No, I fucking hate weekly homeworks, but it's okay. They will probably be one question. Now you may be thinking to yourself, well, that sucks. Usually one question is harder. At the beginning, it won't be harder. It'll be conceptually harder. The first 6 weeks of this class will be, we're not doing long derivations like you've seen in other math classes or other physics classes where you're writing out a page of material. Probability and statistics is about wrapping your head around something axiomatically that can trip you up very easily, right? So it's about thinking really clearly in what you do. There'll be no midterms or exams of any kind, right? Standard, the way we do it. If you haven't had ungrading with me, this will be your first experience. I think you too, right? Yeah, so you never had ungrading. Did you have ungrading, Sarah? No, okay. So it's pretty straightforward. You will turn in your homework as normal. I will give you feedback on it, but I won't write anything at the top. And every 5 or 6 weeks, you'll come in and you'll argue for your grade, and I'll let you know how you're doing. Not with a number or a letter, but with an idea of like, okay, here are the things that I want you to focus on. And at the end of the semester, you make a final plea for whatever grade you want, and I either agree with you or I don't. Is that reasonable? No? Do you like this? Do you like this? Or you sometimes what I'll offer is some people don't want to be on a one-on-one, so I'll offer an exam, and people prefer that. So I'll give you both options. Okay. All right. I'm looking for understanding of the problems. I'm looking for being critical thinkers. As we see ChatGPT and large language models and AI models creep into more and more sections of our education system, the most valuable tool that you will be learning in the next 10 years is not where to find the right answer, but how to know if an answer that sounds right is right. Okay? You will be the experts at discerning bullshit. Right? That is the most valuable thing you can learn as a physicist. And I would argue that I'm teaching 2 classes this semester, which are the most lucrative classes that you could learn as a physicist. The first one is this: understanding probabilistic models and statistics will help you to do any sort of data science in, let's say you don't want to go to grad school, or let's say you get poached by Google halfway through and they offer you a $200,000 salary and you don't even have your PhD. You might take that. Right? Some people get real burned out. They're like, fuck academia. And then the things that they do is they do A/B testing. They do probabilistic models, trying to determine which ways of understanding the way you roll out a package is better, right? So we'll understand how statistics work and how much we can understand about them. And then the other one, of course, is computational, which I argue that modeling is probably up there. If you do anything with computers and the tech industry hires you, you're going to be fine. People who teach, ugh, just kidding. All right. Here's all the relevant policies. You know, I want you to make sure, I think we've already had really good conversations about this because I've had all of you in classes before, but this is a safe learning environment. And if you feel like it's not for any reason, you can always go into the anonymous. I have an anonymous form that I posted, and I'll put it on here as well, that you can go and you can write anything about either how I'm doing in the class, but you could also post anything else you want, right? I'm the only one who ever reads it. And the only thing that I want to make sure of is that we're not using anyone else's work. Okay. It's perfectly fine to work together. It's perfectly fine to work as a group, but copying, especially from something like ChatGPT, that doesn't represent your own work, is not acceptable at any time. Good?
Yeah.
Okay. All right, that's only 15 minutes. Let's go to the course calendar. Easy, right? I filled it out. It was super easy to, let's do 1.5. Hold on. Let's do better. All right, so here's where we are. We're going to understand probability today, or at least we're going to begin to talk about that. There will be no homework due right away. Or maybe I should change this. Maybe we'll have one homework due next Wednesday. We like them due on Wednesday or Monday? Wednesday? Okay, so then we'll have the first homework due on Wednesday. On the 31st. Perfect. And it'll be one problem. Okay, I'll post, don't say no. I'll post them to Canvas and it'll just be a small write-up, right? You just write that up. They will always have due dates. I've gotten feedback before that says, not having a strict due date where I get penalized makes it so I don't want to do it. And I would turn that lens right around and ask yourself, what does that mean? Right? If I need to hit you with a stick in order for you to do something, that does not bode well for the rest of your career, right? Because at no other point in your adult career will you have a job where someone will penalize you for not getting your work done. You will get paid. You will just be not thought of as well, right? So your expectation is to hold yourself accountable. I can hold you accountable as well, but I think that being punitive doesn't really help one's self-confidence. Because then you like pile on. If you say, hey, I couldn't do it this week because my cat got sick or because I got in a car accident, of course I'm gonna let you slide, right? Okay. So here's how it was supposed to happen. I was supposed to teach on Tuesday and we would already like talked about probability, but we're gonna understand probability at the beginning. And then we're gonna do something called Bayesian inference, which is that Bayesian probability that we talked about before. We'll talk about likelihood. Understanding how the statistics that you created to understand the data set, how well do those constrain the data set? And then also we'll talk about data analysis. And I think that gets us up to week 5, which would be President's Day. We'll have President's Day off. And I think that'll finish up the conversation about probability and statistics. That's like 4.5 weeks. Personally, I don't think that's enough time. I would do this class for 15 weeks. But I have legal obligations to teach you other stuff too. So if you care more about it and it starts running long, we can always make this slip a little bit. So we would do special relativity and general relativity with computers up to week 10. And then we would do, conformal mapping and nonlinear dynamics. And then I have a week of Slack called IDK. So we can talk about anything you want. But usually what happens is that I have all these grand goals for how quickly I'll get done with material, and I don't get through it that quickly. So it just slides anyway. Similarly, these check-ins here, these will be your midway check-ins, initial, midway, whatever, final. Those can slide around a little bit. Okay. Questions about this? Okay. Okay, I'm going to, let's see, take this off, I guess. Let's see, how do I want to stop the screen sharing? Where should I put the computer so we can see everything? Well, I have to talk about this next part. Let's do. Oh, God. Oh, God. All right. So there's some stuff on the desk in front of me. And there's money. Okay. Cash dollar bills. Okay, not real cash. So I think I sent an email about this or a Slack message about this. Yeah. There is no ethical qualms about this, right? Religious or ethical. Everyone's okay with this idea? Yeah. Did you get this email?
No, it was a Slack message.
Okay, so let me ask this again.
I have Slack, but I've never been in.
Oh, like.
Like I've downloaded, but I don't know how to.
Yeah, invite you to do that.
Oh, okay. Yeah, no one. All right. So here's the way that this game would work. We would give you money at the beginning. Okay. And you will bet with it. When we go through the process of learning about probabilities. And at the end of however long it takes us to learn about probability and statistics, and we stop betting, you will have either the most or the least amount of money. And whoever has the most amount of money, it's the first top 2 winners, then they will get a prize. Now, one thing that I have to say here is that there will be no ties allowed. Because one way to game theory this would be, well, if we all just never bet, then we'll all have the same amount of money and we'll all win the top prize. So any tie will pass to the person below you. Okay? So you have to be a little bit cognizant of this process that's going on. Okay, so I'll be the bank, I'll be the house, because I have tricks, right? We're gonna have a couple different types of betting, and we'll try and probabilistically understand them. So we'll understand what these are and how we think about probability. We have different color dye that's separated with a beautiful rainbow. It wasn't a perfect, but I tried. And then we have points. Okay, so come take a stack of money. Not these stacks of money, one of those stacks of money. And if you don't mind sitting a little closer, because we're gonna do an activity right at the beginning.
Yeah, sure.
Oh,
Because you don't have to sit that close. Okay, so let's play a game. Okay. And we're gonna learn about how we bet and what it means. We can get into the ideas of money lines later. Does anyone know what a money line is?
No.
Okay, so usually we have odds. So if I was a real Vegas casino, you would do something like, I would give you, say, maybe 2-to-1 odds. That is to say, for every dollar you put in, you could win $2 on top of your original bet. Okay. So if I give you what's called even money, that would mean that for every dollar you put in, you could win $1. Generally speaking, that is a 50-50 bet. Right? The probability is that you will 50% win and 50% lose, and the house will make money, right? Because generally speaking, they'll even out. Now, if you have a 2-to-1 bet, that is to say, you could make twice as much money as you put in. Do you think that the probability of winning is higher or lower than 50%?
Low.
Good. All right, perfect. So we're just testing our intuition here, right? Okay, so we have cards, and you're all going to get your own cards to build intuition. Now, I said a bunch of words, and I didn't define them. I didn't tell you what probability was, right? I didn't tell you anything about the odds in particular, so we're going to put some terminology up afterwards. But first, we're going to build an intuition, and we're going to use all of the money and all of the probability, so we're constantly aware of what these numbers feel like. Okay, all right. These are not coins. So for the first game, okay, I'm going to deal you a card. Okay, and then you can bet whether or not you think that I will get a higher card.
Okay.
Okay, because if your card's higher than mine, right, then you win. And if my card's higher than yours, then you win. Okay, does that make sense? So I'm going to deal you one card, and then I'll deal myself a card.
Yeah.
So first I'll deal you a card, and based on the information you have, you'll decide how much you want to put in.
If it's time. Just get your money back?
Yeah, if it's tied, it's a wash, you get my bet.
Okay, okay.
Okay, ready? So here's your card.
Are we supposed to-
Okay, I have to see it because.
Does I have to like bet or not bet anything?
Okay, you have to bet something.
Oh, like right now, like the moment you get the card.
The moment you have the information, you're betting $1, so you're not very confident in this bet, right? So the amount of money that she's putting in reflects the confidence in her bet, right? And in fact, okay, that's my money next. Okay,
First, you
all right, next.
You didn't jump, let me split 2, 3, 4.
Oh my God.
We
oh my
did.
God.
Are you sure?
One.
What was I gonna say?
This is rigged.
Why do you think this is rigged? What are you talking about?
This is rigged.
We can count.
What are you talking about?
I'm not betting anything.
You have to bet at least something. You have to show your confidence here. All right, good.
What? Give it 5.
Why? Are you gonna give up a 5?
Your iPad, sure.
What's the dumpling?
We don't know what the prize is, but yeah, they could be.
Okay, good. So we all bet exactly the same and you all lost exactly the same.
Okay.
So you knew right away that something was wrong, right?
Yeah.
So what, how did you know that?
Pattern.
Yeah, but, okay, hold on. So you said we can count.
And we,
Well, we assumed a pattern.
Yeah, you assumed a pattern right away. Right away, you thought there was a pattern because you lost and you lost. Right? So something didn't smell right. What didn't smell right?
That you didn't shuffle the cards and add randomness to the deck.
Okay, so there was a lack of perceived randomness. Now, how did you determine there was a lack of perceived randomness? So you said it was just this, the ordering of the cards come out, or the fact that both of you lost?
the
Order.
The ordering of the cards. So the lack of randomness in the card structure demonstrated that yes, in fact, I rigged the deck and I grabbed a very particular deck so that I would win if we played twice in a row, right? Okay. So that means that we don't necessarily trust something if it doesn't fit the patterns that we see, right? Okay, but you all lost the same amount of money, so no one's actually upset. And you just got that money. You didn't have any money to start with. Okay, so this is part of the learning process. Another way that you could have noticed that it was rigged against you was the fact that you all lost, right? And if one of you had lost, and then the next one had won, would you have suspected that there was a pattern? Because what if, for example, the same two cards came out here, but then she won, but the cards were in opposite order? Let's say I got the 4 and she got the 5.
you keep seeing that.
Yeah,
You've seen it happens, right? So the fact that all 5 of you lost seems very improbable, right? Because in a game of higher or lower, what is your expectation that you should win? About 50-50, right? Because you could get one card from anywhere else, and then the chances that the other person randomly gets the next card, right? So we can demonstrate that it's true. We can find out if that's true. Let's try it again. How many times do I have to shuffle, by the way?
4.
4. Okay. Anyone else? Did you guess that?
Yes.
I'm on the right number.
You shuffle with my heart. That's good. Yeah, that's the way you want to put it into it. Interestingly enough, we'll demonstrate this. You say 7. Casino also says 7. We can demonstrate what the correct number is, but there is a probability. Maybe I'll give this a homework problem. There's a way of demonstrating that no two cards of decks have ever been arranged in the same order from a shuffle.
Oh.
Because there's 52 factorial
Yeah.
combinations. So we'll talk about that when we get into combinatorics and probably the end of next week. Okay, do we want to play again?
Yes.
Yes, no?
Yes.
You don't want to play again? You don't want to earn your money back? Okay, we'll go around the other direction. Who wants to go first?
Oh.
All right, Sarah.
All right.
Okay, your first card is a 3. She wins $1. So interestingly enough, what was your probability of winning?
Oh, really low.
Very low. Let's leave these cards out. You'll notice that we have a 3 and a 2 that are still out. All right, anyone else want to play?
I'll go.
Yeah, interesting, right? Buyers or more. All right, so here's your cards. It's a 10. 10 of diamonds.
Oh.
50.
He has to be lower.
I have-
being on the game.
Yeah, I have to be lower than his card. If I'm higher than his card, he loses the money. Very nice.
Easy.
Oh,
Easy.
all right, who's next?
Thank you for volunteering. There's only 5 ones here.
All right, your card is a king. Now, aces are higher than kings.
All of it.
All of it. Everything.
You can bet anything you'd like.
Everything but.
Oh my god, I couldn't fucking do that.
You're betting everything but your ones.
Yeah.
Oh.
Let's go.
All right, so that was, I'm gonna give you another 50. I'm gonna give you 2 more 20s.
Oh, you have to scoot closer. You can't be that far.
Hey, you can't be that far away.
Closer, because you can't be that far.
Yeah, too far.
Yeah, you can sit here.
Well, we're playing games right now, John, so.
Also, take a pile of money.
No, let me give you pile money. Now it's gonna get. All right. So currently the richest person in the class is Isabel. The game we are playing is higher or lower. You will be shown one card.
Okay.
And then if my card is higher,
Okay.
you will lose the money that you put in, but if my card is lower, you will gain exactly what you.
Wow.
I've
So
never.
he played what, for $5?
Where's your money? Okay.
And then he got bold, he said 50, and she got a king, and they said, put it all with the ones, and she won.
I've never seen double-sided Monopoly money. I thought like.
I thought that's
basically.
Oh, don't worry, I paid extra for this one.
I don't like.
Wait, what version did you buy?
Okay, it's called Game of Money, it's not Monopoly.
Game.
TM unrestricted, okay, you guys want to play or not?
Sure.
Well, which one?
Don't you? Go ahead,
I'll let her go
Alright,
first.
so here's your card.
yeah. Here.
So keep in mind, these are the cards that are out of the deck.
Oh, okay, okay, so we get to see that,
Yeah.
got it.
All of this information is for you.
Nice.
Is that really?
$5.
It's
Never
$5.
take it to the casino, bro.
Just never. Is this like the rest of our money for the whole class?
Yeah, until we're done with.
Oh, okay, okay.
And the winner, the first two winners will receive a prize.
Okay.
And ties will immediately go to the next person.
Okay.
Yeah.
What happens if we spend all our money?
On what?
Like that. You
Like we
lose it.
gamble it and there's like no money left.
Lots.
Yeah, you can buy in 2 more times,
Okay,
but every time that you buy in, you drop yourself a ranking. So even if you had the most money at the very end, like if you bought in once, you would automatically be second,
oh, that makes sense, okay.
okay?
Yeah, I'll do,
Wait, you have to start your.
oh, sure, well, I already know what I'm gonna be betting regardless. Oh, yeah, let's do, I'll do 50. I'll do 50.
Okay, do you understand the rule? Do you understand the
Don't
rules?
you want higher cards?
So if I have a higher card, I will take your 50.
Oh, now I see, I thought we were collecting cards.
No, no, no.
Oh, okay, then in that case,
We're
low,
collecting money.
$1,
Very good.
now I see, okay.
All right.
Got it. All right, I misunderstood, I thought we were collecting all of those cards. No.
Okay.
I think I deserve a bit for help.
Good, so now we have understood a little bit about how the gambling will work, okay? We'll talk a little bit about the axioms of probability, and we'll use those to understand how to calculate more complicated probabilities. So for example, when he got the 3, let's just assume that we don't know anything else about the deck. What's the probability that a card is higher than?
There are several cards.
There have been.
There's only 8 cards that are 3 or under, which is.
8 cards that are 3 or under?
Yeah, which is.
Well, 3 is even money, right? So we don't mind the 3.
Yeah, so
So
we.
what are the cards he's gonna
Those
win?
two, one, and then so that's 8. Because of like the heart, king.
So the only cards that can win on 3 is a 2. And how many 2s?
There was 3 because we already.
Oh, yeah, no, but assume that we didn't know anything about
So
it.
then 4.
Sorry, sorry.
4.
4. So only 4 cards could have come out that would have allowed him to win. So that's why he switched from his $50 to his $1.
Right.
Because he knew he was bound to lose. So he said only 3 cards can, or 4 cards can win out of how many cards? Let's assume that we hadn't done any cards.
52.
No,
Oh,
You removed the 2.
oh, 51 then, right?
51 because he saw the
Yeah.
3.
That's right.
Okay, all right. So what does it mean to construct probabilities and why do we have to be careful of them? Let's do another example really quickly. Let's pull just the aces, okay? And I'm gonna show you the aces so that you know that the aces are there. Okay. I know this seems like it's not learning, but it is. Okay, 4 aces, right?
Yeah.
All right. So I am going to shuffle them up. Your job is to get 1 red ace.
Okay,
Okay. Who wants to play?
I'll go first.
Oh, we just pick
Yeah.
from your hand?
No, I'm gonna deal.
Oh, I see.
I'm shuffling them up.
Yeah.
We did tricks at the beginning, there's no more tricks.
That's fair.
You have the red hair. You should-
I'll go first.
Yeah, that's how it works.
Okay, so you want
Sure.
put money in?
Oh.
Do you have? We can't play these games.
I'll
without
do
you
no.
betting.
I'll do it.
Hold on. Pause for a second. Let's understand why we're using money.
Right.
in order to understand these probabilities and have them be meaningful, you have to have a stake in their understanding. We're trying to develop an intuition. So we are going to feel our hearts, like when you put in all of your money, except for the ones, right? You're like, okay, let's go, right? That has a specific sensation that will help you remember. Now, you don't want to tie that to probabilities that are very low. Like if you get something that's very unlikely, like getting the 2 after the 3, and you win huge, right? You might allow yourself to be swayed away from what we think is probabilistically favorable. So generally speaking, we should not bet on anything that is less than 50-50 odds. Because at least if I do it many times, 50-50 odds, I'll break even. So if I start with a coin like this, and I say, every time I flip heads, you get $5, and every time that I get tails, I get $5, would you play this game? Yeah, that seems fine, right? Because more often than not, it's gonna even out. As long as you play it like 100 times. But if I said, okay, I have 2 coins, and I flip both of them, and they're both heads, then you get $10, and any other time, I get $3. Would you play this game?
Yeah, I would.
Oh, she still would.
Yeah.
Okay, so this is why we need to use the money to sort of create these understandings about what the meaningfulness of these games are. Okay, so right now, there are 4 cards. How many cards can you get in order to win? How many do you need?
Usually one.
You just need 1, and you need 1 what?
One red.
Red. How many reds are there?
There's only 2 reds.
2 reds. So you have what odds?
50-50.
Ah, is this a game you can play?
Yeah. Yes.
No?
So yeah, no.
Okay, all right. How much money do you want to put in?
$1.
You put in $1.
That's fair, low risk.
Low risk.
Yeah.
Oh, nice, there you go.
There's your $1. Now she regrets it, right?
There is
Okay,
no way.
Okay, now hold on.
No, we have one.
So here's the question, right? Okay, you've seen the red ace come. Do you want to bet more or less?
Less.
That's like 30%.
30.
For what, the second one?
Yeah.
Yeah, because if you didn't pull that red, it would have been like a 66.
You would have to.
Okay, so now what if I do this?
Now it's back there.
Yeah,
So now it's even, right?
Yeah.
Okay, so let's try something else. Where's my cards? All of my cards in here. Okay,
Can't do
well, you'll learn. You're all gonna get one of these decks. This will be your homework. You'll get decks and dice.
To shuffle? Oh, yeah.
No, you don't have to practice shuffling. You do. But it will be helpful for you to practice learning how these probabilities work. And I know this seems like this is not a math class and not a physics class, but I guarantee you there's some deep knowledge to be learned here. Okay, so let's say now instead, I need a red card from here.
It's still a 50-50.
Red
because-
or
Red,
red ace?
no, just red.
Oh,
Isn't it still 50-50? Because it's like half red.
Yeah.
that is.
I'll bet.
All right, who wants to play?
I'll bet.
Okay.
Okay, so this game would be called Smoke or Fire. Sarah's hand is up first. So this is the game. So
Yeah.
Smoke or Fire. Higher or lower is another game. Okay,
Oh,
all right, so that's $10.
Yeah. Alright, guys, I can lose.
Ready?
Wait, what did you get? Wait. Which one?
You actually want red.
Damn.
Oh, no.
That's
10.
Ten.
I got.
You're betting 10 too. Okay, that's fair.
Yeah.
Are you playing?
Yeah.
a better chance.
I want fire.
Wow. Yeah, because black is gone.
Yeah, by like 1%.
Still.
Hey, 1% is 1%.
Are you playing 10 as well?
Okay.
Oh, wait.
Wow.
No, I'm not cheating. Here's the deck.
Oh. Wait,
That's pretty
good. Let me see.
There you go.
There you go.
You gotta shuffle it, yeah.
Okay, anyone else?
Oh, crap.
Why?
So 2 reds have come out. You should be more eager, right?
Right.
That's all.
Only dollar, okay.
And bro.
Wow, that's.
I'm not cheating.
That is pretty good.
I am not cheating. So why
So now-
are you claiming I'm cheating other than just feeling like you should win?
Because we all lost.
Okay, so let's ask a different question. Okay, what was the probability?
It's basically 50-50. It's people like a
Right?
coin flip.
So if I flip this coin once, what's the probability that I get heads?
50.
Okay, so let's do it. Heads.
Okay.
Next one.
Any coins?
Heads.
I have 3.
Oh, okay.
And there's 3 and then 3. Figured out.
All right, all right.
Okay, next. Heads. That's a tails. Okay. Next.
Ring.
Well, right now it's even. Hey,
Yeah,
that's another head. Okay. So I would have made money. It's great, but I could have lost all three.
Yeah.
Can I have the rest of the coin cards back?
Yep.
Okay, so that was our first example of how we think about probabilities. Let's talk a little bit about theory. No, not theory. Theory. Okay, so this is the book that we're using. It looks awful, but it's great. We're gonna talk about probability today, and in a few days, we'll talk about statistics. So in the context of probability, we want to think of this as axiomatic. You know what this means? So what this means is that where we have sort of intuitive rules and truths that can be inferred about things like the mass of the electron and the spin of certain particles or the way that planets move around one another, we have to instead observe the way that probabilities work and create rules, mathematical rules, such that we can begin to understand them. So we create axioms. And those axioms are basically laws that I just state, right? And you're like, sure, whatever, bud. And then we build on those laws and we say, as long as this is true, then this follows from that. Okay. All right. Let's break some definitions down first. So a single performance of an experiment is called a trial. What would be an example of a trial that you just saw?
This is a single point flip.
A single coin flip. Correct. Right? Or whether or not I gave you a red or a black card, right? Okay. And then we're gonna say something along the lines of, there's this thing called a sample space. You heard of this before? Why is it also so dark?
That's the lights are on.
But what, but I clicked.
There was a bee that was dying in the light yesterday.
Are those related? I mean, that's interesting, like, did it get into the lights and like,
Yeah.
show up?
Oh, wait, no, it's the one that's on, never mind.
Oh. Huh.
Why would a single key fuck?
No, because.
It was creeping in there.
No, because, yeah, because yesterday PK's lab or PK's room entirely lost power. So I was wondering if those two were related. They're not, okay. All right, so we call the sample space big S. Okay, so we're gonna learn math letters too. What is a sample space? A sample space for an experiment is the set of all possible outcomes of a trial. And there are some words in your math words, set of all possible. So let's look at a single trial of us flipping a coin.
Oh, it's either heads or tails.
Heads or tails, okay, good. So let's call it H and T. What is the sample space?
This total two.
What's that? Both of them. And you made this shape, which I really like. Okay. This is S. H and T. Good. Makes sense? Okay. Okay. Sometimes you have, multiple different types of outcomes in a trial. And some of them may overlap with other forms of that outcome. Okay. So let's do a different example really here. Let's say I have a bunch of people in this room. And okay, we'll do older than 21.
I think that's everyone, yeah,
All right, we'll do,
good 25.
okay,
Yeah.
let's take a sample of people.
Yeah.
Let's take a sample of people and we'll ask them, do you live north or south of these mountains that are behind us?
I don't know which. I don't know where you're-
All right, let's ask a different question. Yeah, sure.
There you go.
I thought we should be waiting.
All right. So let's ask the question, do we live north or south of campus? So let's draw some people up here. North or south of campus? South,
Yeah, but like.
so let's put the word south
You live on campus.
here.
I think I'll think about all things.
Middle.
Just pick one, pick then, so,
South.
everyone else know.
I think most of us are south.
Don't you live here? Oh,
I think everyone might be. Oh, you're
Oh,
living
we're
north? Sure, you could be north for Londo.
No,
Oh, wait.
I think it's south. That's two
Okay,
different
next.
sides here.
For
I
sure.
think you live north.
Yeah,
South.
that's what I'm thinking.
That was the part of south.
Cause you live.
Also south.
Hey.
Rolando wins.
I'm with that.
Okay, that's not a game, right? We're learning these words, okay? So where were the trials? Yeah, right? That was determining the outcome of the experiment. The experiment was, where do you live? The outcome was these things that I did not know. Okay, good. What is its sample space? North and south, okay? So let's draw a box. Okay. And there are two sets here. What are the two sets?
Are they north or south?
Good, north or south. So let's draw a circle around those sets. Good. And there's another one here. Okay. Maybe I'll do it like this so that we can identify that no one's name is north in this classroom. Okay. Are they intersecting sets? What does it mean to intersect? Be in both. So one member would be in both of those sets. So when we begin to think about the possible outcomes, we said, well, there's only two options, north or south. Is that really true?
No.
No, you could have another set over here, right?
East and west.
Right? You could have like east and west, right? So where's Dr. Griswold?
West. I'm pretty sure west. Yeah.
Now that
Right.
And it says,
now that I look at the map, I think I'm more west.
then there's on campus.
Yeah, and there's on campus, right? We didn't even include that.
Where-
Okay, so generally speaking, we have created now what's called a Venn diagram. And it's not a Venn diagram you've ever seen, right? Because it's not funny. Doesn't intersect like chicken or, cow, what is it? There's one that is like bird, beaver, or duck, beaver, and then the intersection of the two is a platypus.
Yeah.
Nice.
So those are like the ways that we've, traditionally seen Venn diagrams in sort of everyday life. But they are a mathematical tool. And they're a mathematical tool that we'll learn how to use in order to construct the sample space. And from the sample space, we will determine which events are relevant to the probability that we want to calculate. Okay. Okay, so we could be interested in individual outcomes, right, in the sample space. So let's call south event A. Let's call B the north. So we would say something like event is the particular outcome interest in S, where S is the total sample space. Okay. Good. We talked about this word intersection. What did that mean?
There's an overlap.
A and B.
Good, good. So let's change the sample set because this sample set does not intersect, right? So I could say something like, let's write it here. Here's A, and B. These are both sets. And the thing about math is that sets live in sets, live in sets, live in sets. Sets is just any grouping, anywhere that I can draw a circle is a set. Okay, so this A-B relationship, okay, we're gonna use the shape upside down loop. Okay, and I see this, I think in my head, I see an N, so I think intersection. It's not gonna be very helpful in a few seconds with this. Okay, so is there an intersection between A and B?
Not right
No.
now.
No, there's no intersection between. So let's change the sample set, so it didn't work. Okay, let's flip 2 points. All right, let's flip 2 coins. What can I get?
2 heads.
Okay, so let's do, which one?
Oh, sorry.
There's
Oh,
one
okay.
for.
Heads, heads.
Heads,
Heads,
Tails,
heads,
tails.
heads, tails,
Or that.
tails, heads.
tails, heads,
And tails, tails.
and tails, tails. Okay, so let's create some new events. So the event that I get both heads is where?
Oh, both heads.
That one.
Good. And we can call that A. The event that we get both tails? And the event that I get a tail?
Oh,
C and D.
C.
Oh, and B. C and, okay, C, D,
So
yeah.
if I get this,
Ah,
this is the probability that I get a tails.
mhm.
We could call that C,
okay.
okay? What about the probability that I get tails on the first flip?
There's two on the, it's the
So
second
because
column.
it's unset.
Yeah, this would be its own set, right? So what is the probability if I flip 2? That I'll get a tails on the first?
What's the probability?
Yeah.
50, 50.
Not 50-50, right? We have to remember how
Ah,
we say it.
okay.
We would say here 1/2. And the reason that we say it this way is that probability is defined as the likelihood of something happening, where 0 is not likely. And 1 is going to happen. And this is the way that we like feel about it, but mathematically, we would say that it's a ratio between all possible outcomes and the probability of the thing that you want to have happen happening. So I would say the probability of A happening divided by all the outcomes. How many times A would happen, right? I can say not probability, but instances. Probability of A is the instances. of A overall outcomes. Okay. And mathematically, we would represent that as
1/2.
no, just general. We have 2 letters that we found.
Oh,
Which one is all of them?
Yeah, which one is all of them?
oh,
Oh, I see.
well, the denominator is S.
X, perfect.
Got it.
Oh.
And then. Okay, so you all did this math right in your head. Boom. You looked up, you said 1, 2 out of 4. 50-50. So really, we'll say 50%. Because we need to be careful here. Okay, it's 50-50, you can think of it both ways. Probability of it happening, if I said 30-40 or 30-70, which one goes which way? Right? So if I said the probability of it happening is 70%, you're confident, you'll bet on it, right? If I said it's 30%, are you gonna bet on that? No, good. Okay, and we had some examples here. So I guess I should have done this earlier. So the event where someone is to the east of us that would have been called an empty set. We'll just put some more definitions over here.
No.
This was the intersection. And no outcomes in an empty event. Is our phase symbol. Zero. That's easy one, right? You can remember that. Okay. So if you think about, okay, so the intersection is the ones that are in both. And the union would be what? One or the other, right? So let's talk here about, see, now I've complicated the letters. I'm gonna redraw these, they're gonna be metaphorical for a second, just so we can see the picture.
Yeah.
I'm not gonna draw what the actual sample is inside of these. I'm gonna draw A and B. So what is A intersecting B? Good. So this piece here is A intersecting B. And what is the union of A? Isn't that great that we just use the same fucking letter upside down? Now, when you type it out, it's not a U, it's like a, but this one's easy to remember because U is union, right? So where do I find the union of A and B?
Everything but the intersection.
So this piece here. This piece here. And not this.
We also include that, but we don't like it.
Also include you, if you have, if the intersection of A and B, that's included in the union. Because the only thing that union is asking is, are you in set A or set B? And obviously the set that's in both of them would be in either of them.
Okay,
Okay?
yeah, I was about to say, cause like union kind of implies that
Yeah.
Union is together, everyone's happy, right? Not like my family. All right, so we can actually do math with these, and we can learn some other things too. So let's learn the last one, which is the complement. I don't know if I spelled that right.
I think it's a, no, it's after the L, it's, I think it's.
I don't know.
I don't know.
I'm barely good at drawing, so I'm not gonna be good at spelling. We have to know our strengths. Spelling is low.
Yeah,
I'm a real bad speller.
Same here.
So I'll just tell you that that's not spelled right, and if you want to write it down in your notes properly, more power to you. So the complement of A would be everything in the sample space that is not A. So what does that mean?
Just B.
Just B?
I feel like the intersection of A and B couldn't be that.
Right.
So is this included in the
No,
complement
no.
of A? No, because it's in A. So what about B?
For sure B.
For sure B, okay. So this is supposed to be a different color and it really is not. Good, am I done? No, why not? Right, the sample space itself extends outside of where A is. There's all of these outcomes that live outside of A. Very good. So this yellow color complement. Good. And finally, you can have like combinations of these guys. So here's a little fun one. A minus B. What would that mean?
Is that anything that's only in A and not shared within anything else?
I mean, anything else.
So like the little like intersection of A and B, that wouldn't be included?
Right, so this one, it specifically says, the stuff in A minus anything that's in B. Yeah, so I would say something like this. Right up until this line. Right? I'm sorry that it's super complicated in here now, but it would not include this.
Yeah.
Because that's in B. Good. So if I said that same thing, if I said A minus A complement, what would that mean?
I think with the intersection,
What's that?
same thing with the intersection.
So. Let's look at this first one again. A minus B is A subtracting anything that's in B. And A minus A complement, what did A complement mean?
That's like everything else.
Anything that isn't A. So A minus A complement is,
Nice.
Ooh.
Is that like an identity?
well, yeah, I mean, you can figure that one out. These are just axioms, right? When we define things like sample space, when we define things like a trial and an event, we will naturally get these laws. So when we deal with something like a Venn diagram, which doesn't seem like it makes any sense at all, suddenly we can understand it. Oh, just across the time. 11:45, right?
45.
All right, we can give you one more gamble before the end of today. All right. All right, there are, if you go into using Venn diagrams, there's things like commutativity, associativity, distributivity, and idempotency, which talks about the intersection of A with A would be A, right? Because they are the same. That'd be the identity, right? Commutativity would be that A intersecting with B is of course B intersecting with A. And you can look at these ones all up as well. If you write. Yeah, erase this all. Big one, let me go upstairs and steal the big one next to him. Can that work? Sick. All right, here's A. Here's B. Here's C. All right. So where is A union B?
Yeah,
Just the
upper
two-
left little space.
This one?
No, between the overlap, that one.
No, union is everything, you're.
Oh, you need, oh, then it's all
So
of
it's
it.
this,
My fault.
Good. A.
I was thinking
B,
intersection.
yeah,
And the intersection.
yeah.
The intersection, remember, intersection, things coming together. So this is the intersection, so this is A, this one that looks like an N, that B. Okay, yes,
Would it include the parts that intersect the C?
Yeah, because that's.
because we don't care anything about C yet.
Yeah, but
Mm.
it includes it.
Because
So yeah, so if I say just A, right, so if this whole thing is
All
A,
of it.
For A union, will it include the parts, like the little?
this right here. So what you're saying?
I guess it would, right?
Yeah, but like that little part could be A, B, or C.
And we just ignore a C.
Well, right now I haven't said anything.
Yeah,
Yeah.
it doesn't exist, so it's.
Yeah, they could.
Cool. So I could make these different, right? I could say that this is the event where I flip one coin. And it could have two outcomes. And this is the event where I have a second coin, it flips two outcomes, and this is an event where I have three coins, flips three outcomes.
So A union B, are you including the bare middle piece or not?
This one,
Yes.
yes.
Yeah.
Yeah, because these are circles where this whole curvature here is included in A, and that whole thing is included in B. But this section here, I'm also including, which is the intersection of B and C, but only because I haven't cared about C yet. Okay, and I could be more complicated about this, right? So I could say something like, let's call this thing D. Okay, and that's that little, this thing here. Okay. I could say that D is by definition, what?
The intersection.
A intersection B.
A intersection B there. And I can do that anyway, I can say, B intersection B. Okay. That's the definition of D. And now I'm gonna flip this guy on its side. And I'm gonna say that A includes all of D.
Okay.
Mm-hmm.
So that's flipped U, and that demonstrates that one is inside of the other. That is to say that D is a subset of A. Okay, so this means. Whew. So now you understand set theory. Just kidding. That's the beginning of set theory, and sometimes we say that it contains, right? A contains B. Okay, or A contains D in this context. We talked about the probability theory. Can probability go less than 0?
No.
No, why?
Either it happens or it doesn't, but it can't be.
Right. So if I have 1,000% confidence that this will happen, what does that mean?
It's
It's
a
just
one.
one.
That means that I'm exaggerating,
Okay.
right?
Scaled it out.
Shut up, Chris Money. Okay, so we will talk more about how we can add and subtract these probabilities. But let's do let's calculate the probability of drawing an ace or a spade from a pack of cards. And before we calculate the probability, let's bet,
Okay.
right? Because this is how we care.
Ace or spade.
Spades.
So like any ace or any spade.
In your head, you don't want to help your friends out here.
They're friends.
Well, you want them to lose money, right? So you can win whatever the Tesla driving or gift card to Starbucks.
Oh, you were trying for
That shouldn't be a thing. Oh, man.
We haven't discussed terms yet. We'll discuss terms after
Okay.
the weekend. Does anyone want to play?
Yeah, I want to play.
Okay, so the probability here is what? Calculate the probability of it being a spade or an ace.
So
You just said it in your head, you're gonna make your decision, and you're gonna bet accordingly. Right? Anyone else wanna go? You're welcome to calculate it first, but you can also just bet.
Let's go to bed.
Oh my
Yeah,
god.
so it's $10. What would you like?
Spade.
That is a diamond.
I am nauseous.
It's not
Oh, man.
It's not.
No, joking.
I'll bet.
You're betting?
Yeah.
Okay,
Well, that's a little bit higher.
That's 10. I get an ace for a spade.
So I don't go much.
Oh, that's a
I
hard.
will-
That is unfortunate. I would not bet.
Okay, you should.
No, you- No,
It's not 50%.
It's nowhere near that right now. That's not a good number.
it's like 30.
Yeah.
okay, so we calculated something, right? So let's think about how you got that. So you were willing to take a 30% probability, is that
Yeah.
correct?
Yes.
And what did I tell you at the beginning of class?
No.
Don't bet if it's under 50%, right?
Bad.
Let's do it again.
Let's do it again, alright. Alright, so let's calculate the probability really quickly. How do you do that?
So you get the whole,
It's on
the number of all
It's on the
outcomes.
first top.
So
Yeah, it's on
capital
the-
S is, I put 52.
Okay, go ahead.
So it was 52. and then
To what?
Cards.
Good. So I wanna be, mathematical about this, because even though we're having fun. So the probability of an ace or
Spades.
spade. Okay,
So what I did is knowing that there are 4 aces, so it's 4 plus the number of spades. And I know that spades take up a quarter of the deck.
so let's break this down. You said the probability that there's an ace. Probability Ace. Good,
Plus the probability of the spades,
plus the probability of the spade.
but you have to subtract the one.
Ah, but you have to subtract the double counting. So this is the probability of a spade. And we're gonna subtract off the probability of the ace of
Where they intersect. right?
spades.
Okay,
Very good. But what's this one?
that's 4 out of 52.
Yes, 1 out of 13, but let's do, because I need all these numbers to add, good. Subtract them, good.
Yeah.
So this is 4 out of 52.
Right.
And this one?
13.
13 out of 52.
Yeah.
And this one?
Minus what? Wait,
1 out
why
of.
is it plus something?
Oh.
8.
1 out of 52.
Ah, negatives.
I'm not perfect, okay, guys? All right, so what is that?
16 out of 52.
Excuse me?
16 out of.
Yeah, it was a 30% chance.
16 out of 52 is,
Oh,
34.7.
that's like, yeah,
Or 0.307.
4/13.
so we don't take this back, right?
Never.
Okay. Do we like die?
Oh, die.
I like that.
Uh,
Can I have the yellow ones?
in the right.
Yeah, you can have
hand-
whatever color you want. Here's your 5 yellow die. Anyone else want a color?
What do we do with it first?
Well, these are gonna be your die.
Oh.
What? Which color? I got blue.
There's only one blue.
I don't like colors as well as you do. I would call them both blue.
They're purple.
No, that's
No, these are blue.
no,
Oh, yeah,
no.
cyan.
That's like indigo.
Cyan.
I got 51.
I'll let you choose first. I don't know. Really? We're both indifferent? Okay, well,
They close your eyes.
I'll take that. Oh, I messed it up. I ruined it. I'm so sorry. Everyone was going for it. I'll just hold my hand out. I'm so sorry.
We can't all be experts at holding die.
Yeah.
I'm ready.
Well, they're not.
I never stack it like that.
You're gonna be faster, huh?
Yeah. Yeah.
Okay, so
Oh,
It's on forever.
we don't have new freshies for you later. So here's your pack of cards. 1, 2, 3, 4.
Oh.
I didn't know who that was going to.
Okay, so these will be your tools for the first 6 weeks of class. And you know, you can do it both ways. You can calculate the probabilities and then you can feel them out. So for example, you know, Sarah wanted to go again. She's like, I can get a fucking spade or an ace, like, I don't give a shit, I'll play again, 30% odds. Because sometimes you'll feel like, well, you know, that's like right there. You know, knowing the difference between something like 75% probability and 60, that's not really intuitive. Right? And even 50-50, if you just do it once and you lose, you're gonna feel horrible about it, right? So as you begin to play with these tools a little bit more, you'll build up that intuition for how probabilistically likely is 30%. Right? Because sometimes it'll be worth it. And at the beginning of class next, I guess Monday?
Yeah.
Monday. All right, we'll learn some other card games. We'll learn, you guys know how to play blackjack?
Yes.
Yeah, that's one that you got for 21.
I thought that.
We'll learn something like Texas Hold'em,
Okay.
where you see information and you can base the probabilities off that, right? So you could say, well, there's a very high likelihood that I'll win here, but the likelihood that I win is high, but the return is low. Or the return is very high, the likelihood is low, and I'm still gonna do it anyway, because if I win, I win loss, right? So this is the idea of gambling. The 2 most dangerous things you'll learn as a physicist are the things that you learn in this class and how nuclear weapons work. And you learn both of those things as physicists. So you may develop, and I hope that you do not, gambling addictions, because just like everything else in life, this can be very addictive.
Yeah.
And this is why we're playing with no real money. And if you ever feel like you're slipping, please come to me. No, this is a very real thing,
Okay,
right?
it is,
People,
it is.
I have family who have gambling addictions. And they always think, "Ah, if I just put it all in, I could get it all back. And let me tell you, they never got it all back.
Yeah,
There's a reason why casinos make money. It's not because they're lucky.
yeah.
Okay. Questions, comments, concerns?
No.
You're
Are we,
welcome.
are we keeping this until we like?
You're gonna keep them and you're gonna keep your money. I can either take your money back right now and we can put it into a repository so that I always like at the end of every day, we can total up your winnings. So you can see that in a Google sheet, or
I'll feel like I'll ruin these, they'll get like messed up, so yeah, I'll let them, I'll leave this
Okay.
off.
all right, so let me take your money and we'll separate it.
I didn't even count it, but I trust you.
Oh, you should count it. Write it down on your paper, see how much you have,
Sure,
Yeah,
sure.
you should.
because then if I mess it up, right?
84.